All right, it's that time of year when we wrap up with the semester exam. So here's a video on the semester exam review. I'm going to go question by question through each one. So feel free to skip ahead if you'd like. Pick out the problems that you struggled with. If you got the other ones right, maybe you don't want to listen to me talk about them. So that's fine. I understand. So go ahead and follow through the problems that you need a little explanation with. I'll go through that and you'll be all set to go for the semester exam. So similar question types in the exam, but it will also be multiple choice. So let's get going. First one, find the distance between the pair of points. So you can memorize the distance formula. Square root of x1 minus x2 quantity squared plus the quantity y2 minus y1 squared. Or you can just use Pythagorean theorem. A squared plus b squared equals c squared. So this is 1, 3 units. C, so 1 squared plus 3 squared equals c squared. So 1 plus 9 is 10 equals c squared. So c would be square root of 10, be our distance. And let's check the answers there. All right, excellent. Moving along, solve for x. Well, that's the midpoint, so it's the triangle midsegment. So this segment is half of NL. So if AB is half of NL, why don't I just double that point and make it equal to NL? So then it's a matter of doing some algebra. 2x plus 36 equals x plus 27. And if I subtract 27 from both sides, I get 9. And if I subtract 2x, excuse me, I get 9 equals negative x. So x would be negative 9. And that means negative 9 plus 18 would be 9. Negative 9 plus 27 would be 18. I check my work. It makes sense. We're good. All right, next problem. Most specific name, one pair of parallel sides and opposite sides are congruent, so it's an isosceles trapezoid. Here I want to solve for x, and I know that in a quadrilateral, all four angles have a sum of 360 degrees. So I can just add those up and set it equal to 360, and I'll be all set to go. So 70 plus 180, or sorry, 77 plus 80 plus 88, 168, 175, 245, plus 23x equals 360. Better check my math, make sure I'm adding that up right. So subtract 245. And once I subtract 245, I get 115 equals 23x. Divide both sides by 23. And we get, I believe, 5. Let's check the work. Good. Next problem. This is a trapezoid. And we're going to assume it's not given to us, but I believe the diagram is supposed to say that this is a mid-segment. So if that's the mid-segment, x plus 5 is half of the sum of these two. Should be halfway between. So 8 plus 26 divided by 2, as VU should be the average of those two segments. So 8 plus 26 is 34, divided by 2 is 17. So x plus 5 should equal 17. So if I subtract 5, x will be 12. Next, solve for x. The figure's a trapezoid and isosceles trapezoid on top of that, which means base angles are congruent. So those two are equal. So I've got an equation, subtract 23 from both sides. And I've got 42 equals 7x. Divide by 7, x has to be 6. And we check our work, and it hopefully is correct. Next one, find the area. Triangle is base times height. Base, height, so area equals base times height divided by 2. So 8 times 4.7 divided by 2. And when we simplify all that, we'll get 18.8 miles squared. Area of trapezoid. We could break it into triangles if we'd like. And why don't we do that? We've got, maybe we don't have enough information for that. Let's just take this figure and give us another one over the top of it. So another 6.9 on top, 2.7 on the bottom. And that gives us a parallelogram, base times height. We got to divide it by 2. So let's add up the base. 6.9 plus 2.7 gives us 9.6 times the height of 3.7. And divide it by 2 since we don't want this extra part. So 9.6 times 3.7 divided by 2 gives us 17.76 miles squared. Name of the polygon. Well, 3-sided is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon. So 6 would be a hexagon, 7 would be a heptagon, 8 would be an octagon, and 9 is the wonderful nonagon. And 10 would be a decagon, 11 would be an 11gon, 12 would be a dodecagon. Everything else would be the n-gon, 13gon, 14gon, 15gon, and so on and so forth. Concave, convex. Concave or caved in. This one's caved in. The other way to think of it is extend the lines. If the line that we extend, any line extends, goes into the figure, it's concave. Regular or not. Regular means all sides, all angles are congruent. This obviously is not. So we'd say it's not regular. Find the measure of one interior angle. Well, one way to figure that out is to remember the formula, but chances are maybe you forgot the formula. So let's just create some triangles to figure out how many degrees are in this triangle, because then we can logically figure out the angle of each since they are regular. So if we start at one vertex, we're going to create triangles. Split this figure up because we know a triangle has 180 degrees. Like these wonderful triangles. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. And each triangle is 180 degrees. So we have a total of 1800 degrees. And we've got how many angles to find? Well, if we can count the number of sides, that'll tell us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll divide each one by 12. And 1800 divided by 12 gives us 150 degrees for each angle. And there's that formula if you want it. Number of sides minus 2 times 180. We can divide by the number of angles to get each angle. And the measure of one exterior angle. Exterior angles, they have a sum of 360 degrees. So if I've got my exterior angles on this octagon, I mean I'd have 8 exterior angles divided by 8. 360 divided by 8 is 45 degrees. Interior angle sum. There's that where that n minus 2 times 180 comes into play. Or, if you forget that, create triangles, count the triangles, multiply those by 180. 1, 2, 3, 4, 5, 6, 7 triangles, 180 each, gives a sum of 1260 in that particular figure. Next, find the area of the regular polygon. This is like that big nickel problem we did. So let's just split this figure since I don't know the formula for the octagon. I do know a formula for a triangle though, base times height divided by 2. And make some wonderful triangles here, and I've got 8 triangles. Base times height divided by 2. Well, the base of each one is 8.4 since it's a regular polygon. Times the height of 10.2 for each triangle, divided by 2. Since I have 8 of them, multiply by 8. I do that math quickly in my head, and I get an answer of 342.7 units squared. Solve for x. Polygons are similar. If they're similar, angles are congruent, sides are proportional. So 40 to 48. In the same way that 15 corresponds with x plus 7. I need to make sure to match up corresponding sides, set up a proportion. Once I do that, I can set cross products equal. So 15 times 48. 15 times 48 is 720, equal to 40 times x plus 7. So distribute that 40x plus 280. Subtract the 280 from both sides. I get 440. Is that right? I guess so. 440 equals 40x. Divided by 40. X is 11. State if the triangles are similar. If you know, tell why you know, and complete the similarity statement. So, just looking at the figure, I've got vertical angles congruent. What else do I know? No other angles that I can tell off the top of my head. Let's match up corresponding sides. So 77 to 11. That should be similar as 98 to 14. Notice, if I'm not sure which sides to match up the biggest side from one to the biggest side of the other, and so on and so forth. 77 divided by 11, that ratio is 7. And 98 divided by 14, that is also 7 to 1. So I know that DCB has to be similar to triangle D. If I said DC, it's got to be DU, DUV. By, what's that going to be? Side angle side similarity. Here we go. NML. Well, you got vertical angles are congruent. Let's mark that with 4 arcs since we've got a couple other marks on there. This arc corresponds with none other. This one, they don't correspond with any of those. So I've only got one angle, which is not enough information. I don't have any sides. So I'm not really given any information, so they are not similar. Sure, you can have a snack. Let me pause the video for a second. All right, kids got their snack. Maybe you got a snack too. And we'll finish up problem 19. Find the missing length. So here we've got the similar right triangles. So I look to find which side I have. So need to find x. That's part of a big triangle. Where x and 60 and x is the hypotenuse of that triangle. 60 is the shorter leg. I'm going to try and find another triangle that has a hypotenuse and shorter leg. And notice this little triangle here, I don't have the measurements. This little one I have some measurements. 36 is the shorter leg, and 60 is the hypotenuse. So I've got myself a proportion. 60 times 60 is 3600, and x times 36 is 36x. Divide both sides by 36, I get x equal to 100. Solve for x. Parallel lines, so they're split proportionally. 2x plus 1 is the corresponding side with 14, opposite. in the same way that 9 will correspond with its opposite side, which we don't know. But if this is 8 and 14 total, this has to be 6. So 9 to 6. So you got to make sure to match up corresponding sides. So these are both the longest sides, and then these are both the top short sides. So we cross products. 9 times 14 is 126. Distribute the 6. 6 times 12x, or 2x is 12x. 6 times 1 is 6. Subtract 6, 120 equals 12x. Divide 12, x is 10. All right, find the missing side of the triangle. It's a right triangle. I know it's two sides. How do I find the third? A squared plus b squared equals c squared. At this point in your geometry career, you should be an expert at the Pythagorean theorem. So hypotenuse is across from the right angle. So I've got 10 squared plus x squared equals 16 squared. Solve for x. So 100 plus x squared equals 256. Subtract 100, x squared equals 156. So x is the square root of 156. And as we look to see if there's any perfect squares we can factor out of there to put it in simplest form, I know I can divide 156 by 4, and it's 39. So square root of 4 times square root of 39 will give me 2 times the square root of 39. The only factors of 39 are 3 and 13. Neither of those are perfect. And let's take a look. Did we do that correctly? 2 squared is 39 miles. Tell if it's acute, right, or obtuse. Well, if it's right, a squared plus b squared will equal c squared. If it is acute, it will be greater, a squared and b squared. If it's obtuse, a squared plus b squared will be less than c squared. So we find the longest side, call that one c. These two would be a and b. So square root of 10 squared plus square root of 10 squared compared to square root of 25 squared. Squares cancel out the radicals, so 10 plus 10 equals 25. And 10 plus 10 is actually less than 25, so this is going to be obtuse. Same thing, this will be c. So 10 squared plus square root of 72 squared compared to 13 squared. So 100 plus 72. 13 squared is 169. And it's greater. So therefore, it will be acute. Find the area of the triangle. Well, area of a triangle is base times height divided by 2. Well, I know part of the base. I don't know the height. So let's find the height first. That's a right triangle, so a squared, b squared, c squared. So 6 squared plus, let's call that x squared equals 12 squared. So 36 plus x squared equals 144. Subtract 36, x squared equals 108. And it says use rounded values, calculate the nearest tenth. So square root of 108, enter on my calculator, gives me 10.4. So x is 10.4 to the nearest tenth. And I'll use that value to help me calculate the rest of the base. So 10.4 squared plus, let's call this one y squared equals 30 squared. 10.4 squared should give me 108. And equals 900. It's 30 squared. Subtract it, y squared is 792. Take the square root of that. The square root of 792 is 28.1. So now if we want to find the area of the triangle, it's base times height divided by 2. So 34.1 times the height of 10.4. And we're going to divide all that by 2. And that will give us a grand total of, what's that say? 177.3 units squared. Find the missing side lengths. Leave your answers as radicals in simplest form. Multiple ways we can do that. Remember your relationship between 30, 60, 90 triangles. You can solve it that way. Thinking, oh, this is flipped over. Or we could think Pythagorean theorem. So this is y, this is y. This would be 2y. This would be 2y. Y squared plus 4 square root of 3 squared would equal 2y squared. And once we simplify that, y squared plus 4 square root of 3 squared is 4 times 4, 16. Square root of 3 times square root of 3 is 9. 16 times 9, 144. That equals 4y squared when we square 2y. Subtract a y squared, 144 equals 3y squared. And divide by 3. We get 48 equals y squared. And then take the square root of that, square root of 48, to equal y. All right, I did something wrong. So 4 square root of 3 squared is not 144. Really, it is square root of 3 times square root of 3 is 3. 4 times 4 is 16. 16 times 3 is 48. So this should actually be 48. Sorry about that, folks. Divided by 3 is 16, so square root of 16 is going to end up being 4. So y is 4, which means this is double that, which means this is 8. Another way to remember that is when we have the 30, 60, 90 triangle, long leg to short leg is square root of 3 times bigger. Long leg to hypotenuse is 2 times bigger. You could also use your SOHCAHTOA too if you wanted to. All right, here we're going to find tangent. Remember, SOHCAHTOA, tan, opposite over adjacent. So from x, opposite side, the adjacent side, hypotenuse. So 24 over 7. The tan of z, opposite over adjacent, 9 over 40. Let's do that. Tan of z, opposite over adjacent, 24 over 32. Let's say we wanted to find the sine of z. Remember SOHCAHTOA? Very good, S. Get a lot of tans in there. Let's say we're looking at the sine. So sine of z be opposite, adjacent, this is hypotenuse. So opposite over hypotenuse, that would be 24 over 40. Cosine of z would be adjacent over hypotenuse, 32 over 40. And these could then be simplified into simplified fractions. Tan of z is going to end up being 24 over 32. Okay, we can simplify all those fractions down if we'd like. For instance, 24 over 32 can divide both by 8. This can be divided by 8 4/5, divided by 8 3/5. Okay, so SOHCAHTOA, opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So now we want to find the measure of the angle. So this is the angle, let's call it angle A. This is the opposite side. This is the adjacent side. So TOA uses OA. So we're going to say the tan of A equals opposite over adjacent. So in order to find A, we got to get rid of tan. So how do we get rid of tan? Do the tan inverse. Let's do the inverse operation to get rid of it. So A will equal the tan inverse of 3/9. So make sure your calculator's on degrees mode and you calculate that. So tan inverse of 3/9 gives us about 18.4 degrees. So A, the nearest degree would be 18 degrees, roughly. Missing side length, same process. Look at the angle. This is the opposite side. It's the adjacent. A lot of tans here. So OA, SOHCAHTOA, TOA, OA, TOA, tan. Tan of 65 degrees equals opposite over adjacent. Get x by itself, we multiply both sides by 18. So on your calculator, we do 18 times the tan of 65. You get 38.6 is our value for x to the nearest tenth. Area of the triangle. Once again, we got to find base and height. So we got to find this and this part. So right now, this is the opposite. This would be the adjacent. So I take the tan of 62 equal to opposite over adjacent. Let's call it x. Get x by itself and multiply both sides by x to get rid of it on the bottom. So x times the tan of 62 equals 13. And now to get rid of tan 62, we divide the tan of 62 to get x by itself. And so x is going to be equal to 13 times, or divided by the tan of 32, or tan of 62 rather. That gives us about 6.9 for our value of x. So if this is 6.9, we want to find this opposite side. We know the adjacent, so we're going to go tan again. Some problems we use sine and cosine. We're going to string of tans here, but I just got to know which sides you're working with. So let's call this y. The opposite over the adjacent. This time to get y by itself, we'll multiply both sides by 6.9. So 6.9 times the tan of 46 gives us 7.1 for y. So if we want to find the area, we got base times height. So if this is 7.1 plus 13 is 20.1 times the height of 6.9, and we divide it by 2. And that should give us a value of 69.3 units squared. Area, this is a square, so side times side, 36 centimeters squared. Next one, solve for x. So here we got some arc measures. So it appears, excuse me, got a diameter. So this whole part of the circle is 180 degrees. This central angle will equal the arc, so 9x, plus 73 plus 62 equals 180. And we're going to solve that down. So 9x plus 135 equals 180. And subtract 135, so 9x equals 45. X is 5. Length of the segment. All right, so if this is a right angle, the chord split in two, so this is also 18.2. So let's call this y. You can use Pythagorean theorem to find that length. And let's do the math there. So y squared plus 18.2 squared. 18.2 squared is 331.24. And 20.2 squared is 408.04. And we'll subtract 331 from both sides, and we get y squared equals 76.8. Get rid of the squared, we take the square root, and we get y equals 8.8. We're rounding to the nearest tenth. Well, this is a radius, and this is also a radius. So I can subtract 20.2 minus 8.8 to get the remaining portion of that segment to be 11.4. Find the area of a triangle. Base times height divided by 2, but this is a circle, so we don't need that formula. We want the area of a circle formula, pi r squared. So we're given the diameter, divide that in 2, so pi times 7 squared. So 49 pi, which if we approximate and use our calculator's value of pi, that will give us a value of 153.9 centimeters squared. Circumference of a circle is 2 pi r. That's not a very good C. So circumference will equal 2 times pi times radius is 8. So 16 pi. And that's the exact form, our calculator version. If we use 3.14 for pi, gives us 50.3 meters. Length of the arc, we'll think of the arc as a portion of the circumference. If I would calculate the full circumference, well, if radius is 10, circumference is 2 pi r, so that would be 20 pi, would be the full circle. But we want the arc, and the arc is only 240 degrees out of 360 total degrees in a circle. So 240 out of 360 times 20 pi. 240 out of 360 is 2/3 times 20 pi. That's going to give us a length of 40 pi over 3 in an exact measurement. Use your calculator's version of pi to give you an approximation if you prefer. 40 pi over 3 meters is exact as we need it to be. Area of a sector. Well, we're thinking pi r squared, full circle. And just like the arc length, we're just going to take the portion. So the sector that we want is 225 degrees of the 360 in a full circle. So 220 out of 360 times a full circle's area would be pi times radius squared. So pi times 11 squared. Just so happens to be 121. 121 pi times, can we simplify 225 and 360 at all? If we divide it by 5, we get 45 out of 72. And I think we can divide those by 9 again. We get 5 over 8. So 121 pi times 5 over 8. And I think that's as far as we can go. So 121 times 5 leaves us with 605 pi over 8 yards squared. Solving for x. Well, what do we know? Well, I know that this arc, this angle is 96, which, since that's an intercept or an inscribed angle, the intercepted arc would be double that, which would be 96 times 2, 180, 202, 192. Can't think right now. That arc's 192, which means the remaining arc would be 360 minus that. So 360 minus 192 minus 68 will give us 100. So we have 100 degrees left for arc CB. So 8x minus 4 would equal 100. Solve for x, add 4, 8x equals 104. Divide by 8, x equals 104 divided by 8 is 13. Perfect. Determine if AB is tangent to the circle. Well, if it's tangent, it hits at one point, and it's going to be perpendicular to the diameter or radius, which means our friend Pythagoras will help us again. Use Pythagorean theorem to prove if this is a right angle or right triangle. And if that is the case, it's a tangent. If it's not a tangent. So 100 plus 10.5 squared, which is 110.25, should equal 14.5 squared, which is 210.25. And since that is a true statement, yes, we would have to agree that that is tangent. Solve for x, assume the lines that appear to be tangent are tangent. So these are tangent from the same point, which would make these lines congruent. And these would be congruent, as these are both radii. But these are congruent since we could form congruent triangles here. Split these angles in half. So two congruent triangles, so -5 plus 2x would equal x plus 6. Subtract an x. Both sides, add 5. So we have x equals 11. Let's measure the arc or angle. All right, so when it's outside, 2 of the angle plus the minor arc will equal the major arc. Or we refer to those as arc 1 and arc 2. In this case, it's the minor arc and major arc. And those are the intercepted arcs. So 2 of 75, right, plus this, which we'll call x, will equal the full arc. We don't know what that is either. But the two arcs add up to 360, so that big arc has to be 360 minus x. So 2 times 75 plus x should equal 360 minus x. So 150 plus x equals 360 minus x. Add x to both sides. Subtract 150 from both sides. I get 2x equals 210. X is 105. So if this is x, this is 105. This would be 360 minus 105, which would be 255 degrees. On this circle, it's an inscribed angle, vertex on the circle. So this arc will be double that angle. And this arc is 360 minus whatever this one is. So this angle, 52x minus 2, if I double that angle, it's going to be equal to this arc. And that arc is 360 minus whatever this one is. And that just so happens to be 262x minus 2. So 104x minus 4 equals 360 minus 262x plus 4. So 364 minus 262x is what it simplifies after I distribute that negative. So let's add 262x to both sides. And we get 366x. We'll add 4 to both sides. And we'll get 368. And let's see. I have a feeling I did something wrong. It's not coming out exact. Let me see if I can figure out what I did. Oh, I see. 360 minus -2 is 362, not 364. Which when I add 4 is going to give me 366. And then x will be 1. Yes, your teacher makes mistakes after all. But you know that. I make a lot of mistakes here and there. Next one. Sorry. Solve for x. We know that the vertex is outside, so 2 of the angle. So 7x minus 3. So if I have 2 of those, plus the smaller arc, will equal the major, or the bigger arc. So I've got 2 7x minus 3's, 2 of the angle plus the little arc, equal the big intercepted arc. So distribute 14x, let's check my work this time so I don't make a mistake, minus 6 plus 55 equals 20x minus 5. And combine like terms gives me negative 49 equals 20x minus 5. And let's subtract 14x from both sides. And I get 6x minus 5 equal to negative 49. And I add 5 to both sides, and I get negative 44 equals 6x. Alright, what did I do wrong? I'm not getting the answer. Hopefully you're checking my work. Negative 6 plus 55. Oh yeah, that's positive 49. Thanks. Positive 49 plus 5 is positive 54, which when I divide it by 6 gives me 9. Thanks. 2 mistakes in a row. Doing pretty good. Next, we have crossing chords. The 2 arcs, the 2 angles are congruent since they're vertical. The sum of those are going to equal the 2 intercepted arcs. So 135 plus 71 equal to 2 of those angles, which are both 10x minus 7. So 135 plus 71 is 206. That's equal to 20x minus 14. If I add 14 to both sides, and hopefully I do it correctly this time, I get 220. And that equals 20x. Divide 20. Get 11. X equals 11. Next, finding segment lengths. So remember we've got 2 triangles. If I were to rotate this top triangle over, then we'd have similar triangles. So the short side outside the circle correspond to the full opposite side of the other side, 18 to 30. And the other side outside the circle correspond to the whole opposite side, 18 plus x. Cross products, 30 times 30 is 900. 18 times 18. Oh, what is that? I better use my calculator this time. 324. I should know my perfect squares better. Distribute the 18, 18x. Subtract the 324. We get 576 equals 18x. And divide by 18. 576 divided by 18 is 32. So x should equal 32. Next, crossing chords. Triangles. They're similar if they reflect across. So 6 to 9 corresponds the same way that 4 corresponds to x. So 9 times 4 is 36. 6 times x is 6x. Cross products are equal. Divide by 6. X should also equal 6. We got 2 secants. Same thing applies. You got 2 triangles. Little part outside will rotate it over. So little part outside the circle corresponds to the whole opposite side, 9 plus x. In the same way, that little part outside, 9, corresponds with the whole opposite side. 8 plus 10, 18. 8 times 18, 144. 9 times 9 plus x is 81 plus 9x. Subtract the 81. You get 63 equals 9x. Divided by 9x is 7. Center and radius. Remember with the circle, the equation x minus h squared. And we all come back to that Pythagorean theorem. Started with it the very first question. Guess what? We're finishing with it. So remember with the circle, the center is HK. And the radius r. Any point on the circle, xy, can be given in terms of Pythagorean theorem. X minus h squared plus y minus k squared equals r squared. So in this case, negative 2 is going to give me 0, so it's negative 2. And 0 gives me 0, so the center is negative 2, 0. And square root of that is 4, so radius is 4. 1, 2, 3, 4. And look at that wonderfully drawn circle. Look how close that is. So negative 2, 0, and radius of 4. Come up with the equation. So once again, if we have our equation there, here's our center at 4, 1. Radius, 1 unit. So just fill in the blanks. X minus 4 squared plus y minus 1 squared equals 1 squared, which just so happens to be 1. So we can simplify it that way. All right, that's all the questions we have. Sorry I don't have any more for you, but those are all the question types that will be on the exam. Expect similar question types. Exam will be multiple choice, not multiple guess. You should know what you're doing by now. And I just wish you God's blessings on that. Use the talents that God has blessed you with, and make sure to use those talents. Study up, and you will do fine. God will bless your efforts. So God's blessings on the end of another school year, and wrapping up a wonderful study on God's math, looking at how God set up the world geometrically. So God's blessings on your test.